what a logarithm is. So you want to write down your definition. A logarithm is related to the exponential. So I'll let you guys write this stuff down, then I'll talk about it. I think you'll be able to pay more attention that way. So we have seen exponentials. X equals a to the y. When you turn that into a log, the base in the exponential is the base in the logarithm. And then it kind of just goes across the equal sign. So it's log base a of x equals y. Okay, if you're writing this in exponential, a to the y power equals x. Coupled rules with a logarithm, the only thing that can be negative here is the y. The base of the log has to be a positive number. The argument, that x, the thing you're taking the log of, has to be positive. So first, all I want to do is use that definition to go back and forth between some notations. So if I said you have 1.2 to the third equals m, and I wanted you to write that as a logarithm. You do log, the base of the log, it's like a subscript. So what the base of the log is the same as the base of my exponential. So it's log base 1.2, and you just go across the equal sign, of m equals 3. A log is like, the answer to a logarithm is telling you the power. It's saying 1.2 to what power would make it equal n. So on B, if I want to write this one as an exponential, the base of my exponential would be e. The base of the log is the same as the base of the exponential, so we start there. So it would be e to the negative 3 power equals b. I'm going to put a couple up here and I want you guys to do them. Just write the definition. So this one, you start with your base, which was 3. So it'd be 3 to the c power equals 5. D, I did see a few mistakes on this one when I was walking around. If we write it as a log, the base of the log is the base of the exponential. What's my base here? 3. So it's log base 3. Make sure that base is a subscript. It's a small number down to the side. Log base 3 of 9 equals 2. It's always equal to the exponent. Okay. Questions so far on that definition? So you guys already know how to do the first few problems on your homework. Like the first 4 problems are just like this, going back and forth between the definitions. So no evaluating. Now let's try finding the exact value. I do want to caution you. The calculators, some calculators let you change the base, but if you're looking at your calculator on your Chromebook, you have this log button, and you notice we want log base 2. If you use the log button on your calculator, that is actually log base 10. So if you just type log 16 in your calculator, you will get the wrong answer. We can't use our calculator unless it's base 10. So we have to actually think about this one. Couple ways of doing it. if you understand what a logarithm means, you might be able to look at this and just know the answer. Does anybody think they know it? 4, you're right. The answer to a log is an exponent. This is like saying 2 to what power equals 16. You could also write this as equal to x and use the definition to rewrite it. So my base is 2, so we start there, 2 to the x equals 16. And then this is like a question I would have put on your test. We could get a common base, right? 2 to the x equals 16 is 2 to the 4th, so x equals 4. So whether or not you show work on these is kind of up to you. If you can look at that and know the answer is 4, then you don't have to write it out as an equation. But if you don't recognize that, set it equal to x and use the definition to set up a problem like we were solving before. So, B. Does anybody know the answer to that one? All right, if we set it equal to x, how would I write it in exponential form? Yeah. Start with your base, which is 3, to the x power equals 1 over 27. We have to get a common base. So first of all, I need this to be a 3. What kind of power would put it on the bottom? Yeah, -3 power. So my x is -3. Why don't you guys do C and D? If you just want to look at it and evaluate, this is saying 2 to what power equals 1. If you set it up as an equation, your base is 2 to the x equals 1. I'd say probably half of you did this and stopped. If you have to get a common base, 2 to what power equals 1? 0. So our answer is 0 on that one. D, this is like saying 5 to what power equals 25? 2. If you had to do the equation, your base is 5 to the x power equals 25. So common base, and we get 2. So work is optional on those. If you need the equation, write it. If you understand that the log is just looking for the exponent, you can do it that way. All right, let's just keep solving equations with logs in them. So log base 3 of 4x minus 7 equals 2. This is one that we probably can't just look at and write down the answer. But we can change it to exponential form. So my base is 3. So it'd be 3 to the second equals 4x minus 7. And that's an equation we can solve. 3 squared is 9. Add over my 7. Divide by 4 and you get 4. You do need to check your answers on this. What you need to look at, I told you that in a log, both the base and the argument have to be positive. The only thing that could be a negative is what it's equal to. So all you really have to do is make sure if I put this in, will 4x minus 7 be positive? Yes, so it's okay. If that were to give me a negative, then I would have to say no solution because you can't do the log of a negative number. Okay. Next one. So this would be x to the second equals, how do we get rid of a square? When you have a square root, you do plus and minus. So the square root of 64 is 8. So now we check. I have have to make sure that when I put this in, both my base and my argument are positive. Can I use both of those answers? No, we cannot have a negative 8. So our only answer is x equals positive 8. Let's do a few more together, and I'll give you guys a couple to try. Alright, how do I write that in exponential? This is the type of problem that some of you have struggled with in the past. What does a negative power do? 1 over x squared. So then what could you do? Cross multiply. Divide by 16. To get rid of a square, square root plus and minus plus you. Square root of 9 is 3, square root of 16 is 4. So I get positive and negative 3/4. Are both of those answers okay? No. We can only have the positive because the base has to be positive. B. Log base 16 of x equals 3/4. So what would that look like as an exponential? This is one you could use your calculator. We could think about what it means. It's just saying the 4th root of 16 cubed. What's the 4th root of 16? 2. And 2 to the 3rd? 8. Or if you type 16 3/4 power in your calculator, you get the same thing. Check, is that answer okay? Yeah, it's not going to give us a negative anywhere it shouldn't. So our answer is 8. Log base 36 of the square root of 6 equals x. So what would this be in exponential form? Okay, this is like a test question. What would you do? Yep, common base. So 36 is 6 squared. A square root is a what power? 1/2. So we have 6 to the 2x equals 6 to the 1/2. So 2x equals 1/2. Divide by 2, and we get 1/4. For you guys to do a couple on your own. So here are your 2 problems to solve. So the first one, you start with the base, so it's 3 to the 2nd equals x, and 3 to the 2nd is 9, so x equals 9. That's positive, so we don't have to worry about it. Next one, this would be 2 to the third equals 2x plus 1. What is 2 to the third power? So subtract 1, divide by 2, next is 7 over 2. Alright. I would like for you to get out your calculators for just a minute. There are 2 types of logs that we can evaluate on our calculator, and they are very straightforward. I'm going to put a couple up here and just make sure that we can all plug it in correctly. So I'd like for you to do it with me. So we are going to calculate these 2 things. Alright, log of 46 over 17. If you look on the left-hand side, the 4th button from the bottom is just regular log, L-O-G. You push that button, it opens a parenthesis, so then you're just going to do your 46 over 17. Okay, and then typically I will have you round these to 4 decimal places. So it'll be 0.4323. You guys all get that? The other log that we can do on our calculator is ln. We'll talk about this more later. It's the natural log. It's a log with a base of e. But all you really need to know right now is you have an ln button right below your log. So you just hit ln 8 times that e is, if you hit second and the ln button, it puts in the e, and we do our 6th power. So you should get 8.0794. Is that okay? So there's a couple of questions like that on your homework, just making sure you know how to plug those in your calculator. The last thing I want to talk about today, I have a slide with some properties of logs. I'm going to have you go ahead and write them all down today. We will be using them tomorrow. Okay? I may do an example that uses one of these properties today, but if you would, go ahead and write all of these down and we'll talk more about them tomorrow. So there are 4 properties for our logarithms that we need to know. Product, quotient, power, and then the inverse properties. So just write each of these. Properties, so these first 3 we're going to use tomorrow. I just wanted them written down now, so I'm not even going to talk about those 3 today. The only one that we will use at all today is the inverse property. And so we'll talk more about this part later, but it turns out that the exponential and the logarithm are inverses of each other. We talked about inverses in section 1. We had it on our test. We know that inverses essentially cancel each other out. They're opposites. You know, if you add 3, you can subtract 3. Those are inverses. If you do both a log and an exponential, they can cancel each other out as long as the base is the same. So if you have a to the log base a power, essentially that log and that a would drop and you just get the m left. Same thing true if you have the log base a of a to a power, the log base a and the a cancel and just leave us with the r. So I just wanted to show you an example of that, and then I'm done for today. A few of your homework questions are going to use these properties, and if you recognize them, it makes your problem really easy to solve. So if I have x equals 3 to the log base 3 of 8 power, what's my answer going to be? 8. The 3 and the log base 3, they are the same base, so those just cancel each other out and leave us with the 8. Okay, second one, x equals log base 4 of the cube root of 16. Now this one you may not recognize the property, and if so, that's okay. You could write it as an exponential and still solve it. 4 to the x power equals this, and that still works. So if you forget the property, it's not a big deal. But what you might recognize, 16 is 4 squared. So the cube root of 16 is 4 to the 2/3 power. So what's my answer? 2/3. Again, that's not the only way to solve this problem, that's just one option. That is all I wanted to get through today. So there is a handout posted on Classroom. It's like 16 questions, but some of them are very, very short. First couple are just the definition, writing it with a logarithm. Then there's like 4 calculator questions, and then some solving equations. So you've got 10 minutes right now to work on that and ask questions if you need to.